Okay, so today we're going to be talking about integrals, okay? When we write an integral, let's use that same example. So y equals 3x plus 7, okay? Which means that we have this funny symbol here. It looks like an elongated S, and then we put, this is squared, I'm sorry, 3, that's an x there, 6x plus 7, okay? So this funny symbol here is basically what tells you that this is an integral. And this right here is about equal to y prime. So whenever you see this thing, know that it's an integral, know that it's like saying y prime equals. Okay? So now what do? Well, you know how when we have a derivative, 7, we divide the constant by the exponent, and then we subtract 1 from the exponent. Like that. Well, when you take an integral, this is basically x to the 1. You just add 1 to the exponent, and then divide the constant by the total, okay? So then you get 6 over 2 x, 1 plus 1 equals 2, okay? Now, what about when we have just this lone 7 here? What do? Well, real simple. When you have just a number, just add an x, okay? Just stick an x on the end. So we can simplify this, and we get 3x squared plus 7x. Hey, look, that was our thing up here. So one really good way to check your work when doing an integral is to just take the derivative of your answer. So let's do that. Y equals 3x squared plus 7. Y prime equals 6x plus 7. Hey, look, that's what we started out with. Same thing. Means you got your answer correct. If the derivative of your answer is the same as your original integral, then you know you're doing it right. Okay? So let's do an example problem. Say integral 3x squared plus 2x. Okay? Solve this, and we get... Wrong way. Okay. Solve this, and we get x to the third plus x squared, right? Because we add 1 equals 3, divide by this. Here, I'll go step by step with this with you. Okay. So that's 3 over 3 x to the third plus, this is 1 plus 1 equals 2. 2 over 2 x squared, so that's x to the third plus x squared, okay? But now, the thing we don't know is, well, this could be x to the third plus x to the squared, or it could be x to the third plus x squared minus 7, or x to the third plus x squared plus 2. We don't know, right? Because think about it. When you take the derivative of this, no matter what the constant term is here, you're still going to get 3x squared plus 2x. So you don't know. There could be something here. It'll change whether your graph looks like this or whether it looks like this. And, that makes a difference. So what do? Well, we use this nifty thing called plus C, okay? And C is just a random constant. That's all it is. C for constant. Makes sense, right? So our answer in this case should be x to the third plus x squared plus C. Okay? And you always, always, always need to put that plus C. It's really important. Okay. So now we get the question, how do we calculate C, okay? Sure, sometimes it's fine to just say, oh, we'll just plus C, plus any number, What was that, x to the third plus x squared plus C? Well, what if there comes a time when we need to know what C is? We need to know exactly where that graph is. Well, we do this. So let's come up with a integral, say 2x plus 7, okay? And let's say the problem tells us that we have the point 3, 2. That's on our graph. So what do? we solve the integral like normal. So x to the 1 plus 1 equals 2. So that becomes 2 over 2 x squared plus 7x. So that's just x squared plus 7. Okay? And then we say 3, 2. And remember, this is y equals x squared plus 7. So we just plug this in. So we get 2 equals 3 squared plus 7. X, 7x. So we put the 7 times 3. So 2 equals 9 plus 21. Okay? So then we have 2 equals 30 plus c. That's why we don't have a real equation. Okay, don't forget your plus c. See, that's a really important thing to note, is everyone forgets plus c, and you don't ever want to forget plus c. So always remember plus c, because it'll save your life one day. So this is negative 28 equals c. So then our equation is y equals x squared plus 7x minus 28. Okay? And that's how to solve for c.